Welcome back to the Genesis Science Report. I'm David Rives, and tonight we're debuting a new campaign, Age of Design. Now, in this series, Age of Design, we'll explore one of the most important questions in science, the origin of life itself. Together, we'll examine the scientific facts that challenge common theories of life's beginnings and highlight groundbreaking discoveries about DNA and the complexity of living systems. Now, these findings point to one undeniable conclusion: you are designed. Our focus will center on 5 scientific DNA facts supporting design, all of which you can explore further at ageofdesign.org. We believe that science and design are not enemies. They're allies. If science shows that life cannot arise from random chance alone, well, then it's time to consider explanations that reveal our purposeful, designed existence. Along the way, we will be collaborating with some of the world's most brilliant scientists, men and women who are courageously challenging the status quo and exposing the truth behind the false ideas that are often taught in classrooms. This is the Age of Design, where science meets purpose and truth replaces deception. In 1931, 2 revolutionary inventions changed the way humanity could explore life in the universe: the electron microscope and the radio telescope. So for the first time, scientists could peer both deeper into the microscopic world of living systems and farther into the vastness of space. What followed has been nothing short of extraordinary. The discovery of the DNA double helix, insights into cellular protein production, the mapping of the human genome, for instance, and then these breathtaking images of galaxies through the Hubble telescope. You know, each of these milestones has revealed staggering levels of complexity, engineering, beauty, and order, evidence that challenges the idea that life and the universe are products of mere chance. Throughout history, when humanity has reached turning points of discovery, we have named those eras to reflect their significance. Some examples would be the Bronze Age, the Renaissance, the Age of Exploration, the Industrial Revolution, and the Information Age. Well, we believe our current era deserves its own name, the Age of Design. Since 1931, scientific advancements have increasingly pointed to design at the very foundation of life and the cosmos. The deeper we look, the more we see intricate patterns, interdependent systems, and astonishing precision. We're entering a period where evidence of design in nature cannot simply be ignored. This is not a rejection of science, it is a pursuit of truth. We reject censorship and suppression of evidence and the dogmatic allegiance to many outdated, antiquated theories. Instead, we explore the growing body of discoveries that reveal the impossibility of life arising from randomness and the undeniable evidence of a designer. We believe that you are designed. Join us as we explore the Age of Design, a journey of truth through science, discovery, and wonder. Today, we're honored to welcome one of the world's leading scientists boldly challenging the prevailing theories on the origin of life, Dr. James Tour. Dr. Tour is a world-renowned synthetic organic chemist and nanotechnologist. He serves as the TT and WF Cow Professor of Chemistry, Professor of Computer Science, and Professor of Materials Science and Nanoengineering at Rice University in Houston, Texas. With over 750 research publications and more than 140 patents, Dr. Tour has been named among the top 10 most influential chemists in the world over the past decade. Now, his pioneering work spans from nanotechnology and molecular electronics to medicine and advanced materials. But beyond his groundbreaking scientific contributions, Dr. Tour is also widely recognized for his thoughtful engagement on questions of faith, science, and the origin of life itself. Dr. Tour, welcome to the program.
Thank you.
Absolutely. It's an honor to have you here today to discuss these things. So we believe that we're in the age of design, a scientific renaissance of knowledge in discovering the complexity of life systems. So what do you think has been the most significant discovery to challenge the current or the older origin of life theories that we've been taught for several generations?
Wow, there are so many. Previously, it was thought there was a pond and some small molecules and some lightning strikes, and those molecules became more complex molecules. And then they assembled into a higher order structure, namely a cell. And then those cells started to come together and form multicellular organisms. And you then got these creatures in the pond that would then come out of the pond, and that's how the origin of life. Every step that I just told you has been shown to be nonsense. None of that happens. And so every step along the way, there's been nonsense, and the complexity of the cell has gone up dramatically, even since the Miller-Urey experiment, which was in 1953, where they made amino acids were made in a high voltage environment. The DNA was just announced that year. They didn't even know about DNA prior to that. So the cell has gotten much more complex, even the simplest of cells. So there's so much structure there, and we have no idea how that could have formed in a prebiotic soup. So it's everything, and every new discovery of the cell increases the complexity. So we actually get further away from the target every year.
That's extremely interesting, because post-1931, there's been this renaissance in molecular and cellular research, and it's been shaping our scientific understanding of life's complexity, but at the same time, almost has been suppressed because of pre-existing thoughts on the origin of life. Can you talk about that for just a little bit?
Yes, the pre-existing thought is what many of us were taught when we were in school, that this primordial soup. And what's happening now is you see some backtracking of scientists claiming, well, we don't really teach that anymore. They absolutely do. Not only is it taught in elementary schools, it's taught throughout grade school, and it's taught in college, and it's taught in advanced college that way. There are advanced textbooks in biology that will still talk about this primordial soup model, or this smelly pond model. Yeah. Or they'll mention a hydrothermal vent in an ocean. None of that produces the molecules that are needed for life. So this is the prevailing model. And then as soon as you start looking at every one of those steps that you would need, of which there are thousands and thousands of steps, every one of them breaks down. And none of them has been reproduced in a prebiotically relevant way to make a product that itself would be relevant along this course to build a living system.
Well, the Age of Design presents our time as this new era of revelation, not mystery, and yet origin of life theories remain pretty weak in explanatory power and evidence. Why do you think these previous theories continue to fall behind in modern scientific discovery?
Well, I think that, as Richard Feynman, a great Nobel Prize-winning physicist, said, that the easiest person for you to deceive in the sciences, the easiest person to deceive is yourself. You start looking at a problem and you want to find a solution, and you think that the result that you got suggests a solution. Whereas in this case, every result that is gotten in origin of life studies screams out that this is how life could not have happened. The product it's giving you is telling you that life didn't happen that way. And so I think that people are deceived, and then they encourage each other. They publish these papers and they make these bold claims. But then as soon as you stand back and look at it, you see that the emperor has no clothes. There's lots of things here that are just utterly not working.
Yeah. So Dr. Tour, science has now revealed that, what Charles Darwin, when he had these primitive microscopes, he's looking at a simple cell, and he would indeed have thought that it was probably pretty simple. But now we're seeing that, even a single cell is intricately organized. So can you talk a little bit about what are the essential components that makes life as it is possible?
Right. So I'm not sure how much Darwin really dealt with the origin of life. He himself said the origin of life is a mystery. He dealt predominantly with evolution, whereas you say, all right, I've already have the first cell. How does that first cell transform into multicellular organisms and then higher organisms from that? That's what he was primarily dealing with. He didn't deal with the origin of life. He didn't know what the components were that were necessary for life. Right now, we know that. We know what components are necessary. You need four major classes of compounds. You need the lipids, which form the bilayer, a lipid bilayer around every cell. This is like the sac that things are contained in. But it's not a very simple structure. It's actually quite a complex structure. And then the pieces in the cell is you need to have polypeptides, which is the structure of all of our proteins and our enzymes being the little nanomachines that build us. And then you have to have the sugars, which are sometimes called saccharides, and the polymerization product of those are the polysaccharides. So you have to have the polysaccharides. And those polysaccharides are components on our cell surface, components within the cell. There are energy sources. And then you have to have the nucleotides. The nucleotides are the DNA and the RNA. And nucleotides have three different component parts. They have a sugar unit, so you have to solve the sugar problem before you can make DNA and RNA. And then they have a phosphate group attached, and then they have a nucleobase, something that's a basic structure that is going to allow the base pairing within the double helical structure where these things are stabilized. So all of those structures are made of simpler structures. So the polynucleotides are made of the nucleotides. We don't know how to make the components of the nucleotides and have those assemble into a nucleotide and then have those polymerize into the polynucleotides or the DNA and RNA. Every one of those steps we don't know. We don't know how the lipids were made, the small molecules, the lipids that make up the bilayer. And then once you have the lipids, it's difficult, not impossible, but it's difficult to make a lipid bilayer. But a lipid bilayer by itself will not work. You have to have these transmembrane proteins. You have to have ion channels in order for this to respirate, in order to have breathing to occur. These ion channels are made up of very complex molecules. The proteins, you have to have not just the amino acids, you have to be able to polymerize the amino acids. Nobody's ever polymerized the amino acids in a clean form above something like a 14-mer. Nobody's ever been able to do it because these things don't just polymerize. Every one of these polymeric forms has something called a free energy that's positive. A free energy that's positive means that they're not spontaneous reactions. They don't go by themselves. So they have to have special chemical activation. And then the hardest problem is actually the sugars. Making the sugars, we don't know how the sugars would be made. And some of the prevailing views of how those sugars have been made have come crashing down just this year in 2025, in April of 2025. The papers are coming out on that we don't know how to make the sugars. And then once you have the sugars, we don't know how to polymerize those into the polysaccharides. So in all of those cases, we're lost. So we're lost on all the basic building blocks of the building blocks, and then we're lost on all the building blocks, which are the four polymerization products of those. And so we can't even get started on life. Now, once you have all those, then there's a lot of higher order structures that you have to have in order to have a cell structure. And those higher order structures are often through non-covalent bonds, just the molecular interactions that are not hooking molecules together directly, but are stabilizing them through things called van der Waals interactions, which compose of hydrophilic and hydrophobic interactions. We don't know how those got assembled. The magnitude of the problem, the statistical problem in overcoming any of these is astronomical. Way more time would be needed to do this. Yeah. Way more time than in any universe to allow this to happen. So every one of these is a barrier. So it doesn't look like we have any good solutions to this from a materialistic standpoint.
Okay, so what you're saying is that the goalpost is being moved farther and farther away for a naturalistic origin of life.
Absolutely. So in 1953, you could think that, hey, the cell is just a bunch of protoplasm in there. There's not much to it. Certainly in the 1930s, that's what you would think. But now the target has gotten much harder. So even though somebody may say, well, hey, we've gotten closer, the goalpost has moved much further away, and it keeps moving further away every year. And this is the way we track progress in science. We say, okay, how much closer are we to a solution now that we've gotten this information? And so then if you try to track that every year, it turns out that you end up further away from a solution every year because the target, the cell, has moved further away. Not that the cell has evolved any differently. It's just that now we understand more of the structure necessary within a cell, so the target's moved further away.
Yeah. Dr. Tour, you mentioned that, if we go back to 1930, if we go to 1950, how has the sequencing of DNA, which is a much more recent advancement, changed this entire discussion?
Well, in 1953, the structure of DNA was determined, but that didn't tell us how DNA really codes for the enzymes that are going to be needed. That came a few years later on three letters designate a particular amino acid in a protein sequence. And so that's when we learned that. And then there's many surrounding mechanisms that allow the assembly of these little enzymes. But just having that structure doesn't do anything because you have to have the code. So without the code, in other words, just if you have a computer code with ones and zeros, until those are put in a logical sequence that will code for something, nothing's going to run. So inherent in the DNA is not just a random box of letters. So if you just take a random box of letters and shake it up, you don't get a book. I mean, there's nothing you can read. You have to have the coded structure to put that into words. And those words then have to go into sentences in order to have the structure. We don't know how those words were put together. We don't know how those sentences were put together. That's where we are, and so we remain clueless on that. With all our advances on DNA, we remain clueless.
And that's incredible, and that's honest, right? A lot of times things are just thrown out there within the scientific community, and theories, suggestions, ideas are even perpetrated as fact. But to say, hey, we don't know this, that's what science is all about. And what it also means is that there's room for expansion, there's room for growth as we learn more.
Yes, there's room for research, and so I'm very big on research. We have to continue to do it, but also I'm practical. Yeah. So we've been doing research for almost 75 years now, and since the Miller-Urey experiment in 1953, and since the structure of DNA, and we are no closer, but we're actually further away from figuring out life's origin. So we have to change the direction in which we're going, because we're fast falling further away from the target. So I think there's real changes in the way we approach this problem that have to be done, and there is some confession that has to be put out that what we've been doing is just not working.
Yeah. I'm going to get very specific here and see what you have to say. Here's a question. What is life?
So science doesn't tell us what is life. Science tells us the characteristics of life. Okay. So the primary unit in life is a cell. And if you look at a cell, it has to have certain features. And one of the things that it does, it has to have a metabolism so that it can get chemical energy and go forward with its life. It has to be able to breathe. It has to be able to respirate. It has to be able to pass on traits to offspring. So it has to be able to carry on, to have offspring and carry on it, pass on its traits to its offspring. It has to have homeostasis, which is a general operating system running it, that allows it to operate. These are characteristics of life. That is not what life is. Science does not define for us what life is. Those are the characteristics. So what we're really going toward in the lab is a functioning unit that has those characteristics of life. But what life is probably something that is better explained to us by the Bible than by science.
That's extremely interesting. So we don't know exactly, we can't define by science what life is. What do you think is that spark, that energy, that force activating life? Do you think that can be found by going back to biblical accounts?
Well, certainly the Bible tells us that we've been made in the image of God, that God created all things. So in that, we can understand the source of all this is God. But there's not any detail, really, in the book of Genesis that tells us the details of how this happened. Yes, he breathed life into Adam, made him a living being. But what's the details of that? How did the cells start operating? Yeah. Classically, there's been something called this vital force that people thought there was behind life. We really don't know, but it would be very hard to imagine that if you just had all the molecules in the right place, the thing would start operating. Because if that were the case, you'd think you could take a cell that has just died and bring it back to life, and it can't be done. We don't know how to do that. So whatever is moving this from a non-living to a living structure, we haven't identified.
Dr. Tour, you just mentioned something that is incredibly profound. I don't know if we all actually think about that, but you're saying if we have a fully intact, dead, single cell, we've got all of the elements necessary for life. In fact, it was just living, but we can't actually bring that back to life.
That is correct. So you would think that bringing a dead cell back to life would be much easier than creating life de novo from a new form. Yeah. It's the same in any way. A resurrection should be easier than creating the whole structure from the beginning, from the elements of carbon, hydrogen, nitrogen, oxygen, and phosphorus, and sulfur. So these are the elements that make us up, and we have a little bit of inorganics. We have iron and zinc and a little bit of selenium. But you would think that it'd be easier to take a dead structure and bring it back to life because things are pretty much in place. We've never been able to solve that one either. So that's how far we are from this, and we have no idea what it is, what's needed to get it going again so that it starts showing the characteristics of life.
You know, a lot of chemists don't even attempt to tackle the origin of life, but origin of life scientists, those who are studying this issue, how in the world, based on what we've learned just in the last few moments, how do they suggest to bring a concoction of random assembled parts to life?
Well, what they suggest is that if you pull all of these elements together, these four classes of molecules together, that somehow they will start operating together in a life-moving form. And that's never been the case. There's no calculations that suggest that to be the case. In fact, there's calculations of order, of protein folding, of interactome arrangement that argue against that ever happening. There's not enough time in our universe. There's not enough time in a billion universes to be able to make that happening. So statistically, everything's against us. Chemically, everything's against us. And we have no idea how that happens. There's silliness that people are looking at a Marangoni effect of how lipid bilayers might move around in solution, suggesting that is some sort of precursor to life. It is not a precursor to life, not by anyone's definition, except the researcher who's deceiving him or herself. Yeah. That's how far we are. We're very far from life.
You know, maybe this is a bit strong, but in textbooks, in scientific textbooks, in college biology textbooks, in so many things today, there are deceptions, there are inaccuracies, and if I could be even so bold, lies found in those textbooks. Can you tell me about a few of these things that are being taught within the scientific community and to college students?
Yeah, I mean, this happens all the time. Now, I want to say that I don't think any scientists begin writing a textbook and saying, let me lie about this. There's no intent to lie outright. But there are speculations, there are hypotheses that are put forth as fact. And that's highly inaccurate. There are facts within the sciences. Water is H2O, two hydrogens and an oxygen. You may have different isotopes where you vary the number of neutrons, but it's still two hydrogens and an oxygen. That's water. That's a fact that doesn't change. Then there are hypotheses, and people will put forth they'll put forth things in, say, in the origin of life as a hypothesis on how life might have formed, but that is not a fact. And the hypothesis is so weak because it's never been demonstrated. Not only would it not work on an early Earth, you can't even get it to work in your own laboratory. So the hypothesis has no basis. What you do is you're supposed to test hypotheses and see if they could be valid. So there are, you're probably better off not even calling it a hypothesis. There are just so stories that are put forth, and they are projected as if they're fact. And then based on that, it appears that it might be a lie, but there was no intent to make it a lie. But that's how far away we are from an answer. And that happens all the time, not just in origin of life. That happens in evolutionary models as well. There's many pieces of evolution that how you go from an invertebrate to a vertebrate, and how you get that many transformations in a DNA that would have to occur at the same time in the same place to have a transition like that. Nobody knows how that could happen, but it's put forth as if small changes all of a sudden result in a spine to be grown. That's not the case at all. So I don't think there's an intent to lie, but when you start calling hypotheses or just so stories facts, then therein lies the problem.
So based on this, and also based on scholars such as yourself, learning these new things, these new groundbreaking things that we're discovering within the scientific community, how would you suggest we go about trying to recondition the textbooks? How would you suggest we go about trying to get some of these inaccuracies and lies out of what is being taught to the next generation of scientists, who will then continue to perpetuate the myth just because they trusted what was written?
Yeah, I think you have to get rid of the just so stories and look at them as things of the past, as relics. People used to suggest X, Y, and Z. We now know that there is no credible evidence that suggests that hypothesis could be sound. So that the students see that there was a historical progression on how things might have occurred. Just like we put forth historical evidence that we say that the universe always used to be. That was the prevailing view among scientists through the 1950s, that the universe never had a beginning. And then with the discovery of microwave background radiation in 1963, everything changed. That the universe has a beginning. That the vast majority of scientists saw that data, saw the expanding universe, and it suggested that, yes, the universe had an origin point, very much actually similar to what the Bible suggests, that there was an origin to our universe. And so we still teach the steady state hypothesis, saying this is what people used to believe. They used to believe that the universe never had an origin, it just always was. Now the suggestion is it had an origin point. And so we can still teach the old methods, but we say we know from newer evidence that this is not the case and that those very hypotheses do not work, so that students understand this is a very fresh area for research, that we really are clueless on these things, and so let's do some research. And there are ways to do this even within the origin of life research. So for origin of life research, you could say, okay, well, I have this cell, it has just died. What might I be able to do to bring it back to life? That would be probably something that would be more fruitful. Yeah. Or to take a cell and to knock out different parts of it and see where it stops operating, and you bring it just to the verge where it's going to stop operating and see if you can put things back in to get it to operate again. And there have been experiments like this. And there have been experiments where they've knocked out lots of genes, and the cell can do many functions, but it can no longer reproduce, for example. And then they'll put the genes back in, and it'll start bringing in those functions. So these are experiments that I think are probably a direction to go, where you start with life and you start modifying it, say in a cell, and then bringing it back and things like this. That would be a better way to go. But I think that's how you can correct textbooks, saying this is what we used to think. Now we know this newer data suggests that those hypotheses don't work. So we're really clueless on life's origin, and we're clueless on many phases of the neo-Darwinian model, or the Darwinian or newer Darwinian models. There's a lot of gaps there that we'd have to be able to fill in. And there's other ways to look at the same data. And I've covered some of that with my colleague Rob Statler on my YouTube channel, Dr. James Tour, where we've gone through that. So rather than having this tree of life, you look at a little bit different model that actually matches up better with the scientific data, and is much more in line, actually, with what is suggested in the Bible.
So we want to take a break here in a second, but one final question, and that is, when it comes to origin of life researchers, when it comes to scientists in the modern day who are studying these things, are there deceptions involved based on the worldview, the way that people are looking at this? Or is it simply completely blinded because of peer pressure and academic pressure, and this is what my professor taught me, so therefore I have to parrot it?
I don't think that there's an active deception. I don't think that they're going into their science and saying, let me see what I can deceive the world with today. I think that there's they have been deceived, but it's more delusion. Looking at their own data, they're not looking at it in a way that tells us how this screams out, it didn't happen this way. So I think that they're deluding themselves, and the community is deluding itself as well. So that you have other people around you saying, oh yeah, it could have been that. And then they surround it with just stories. Not even good hypotheses, but just fanciful, imaginative stories. And I think that that's what's going on in the community around origin of life. And whatever the scientists say in their papers with their just so stories, the press then ratchets it up tenfold. Yep. And they come out with crazy statements like scientists have finally figured out how life began.
Especially those layman articles, which get exaggerated. I've been speaking with Dr. James Tour. Big picture, here's what we're seeing. When you zoom in on life, chance keeps shrinking and purpose keeps stepping into view. And that's why we are launching Age of Design, to look at the evidence with clear eyes, and just as you've just heard, with plain talk, with reasonable, practical talk. We've set the table. We've brought in scientists who do this work in the lab every day, and next time we'll keep building this out and following the facts wherever they may lead. For now, we've got to step aside, but we will be right back on the Genesis Science Report.